Now let's consider this question. We have 3x squared plus 36. What would we add in order to get a perfect square? Well, if we have something besides 1 in front of x squared, the expansion of x plus a no longer has any relevance. Now we could think of expanding the square root of 3x plus a, and might be worth writing that down, but it's not particularly important for what we would do. So square root of 3x plus a squared is what? Well, if we square the square root of 3x, we get 3x squared. We're going to get then 2 times the square root of 3a plus a squared. This is not particularly helpful, okay? It could be, but it's a little more work than we want to go to. Okay, we don't want to expend that much energy. So how do we avoid having to deal with that square root of 3, if we even understand why the square root of 3 is there? Okay, it's there because that's what you need to square in order to get 3x squared. We don't want to deal with that, so we factor out the 3. Now we have 3 times x squared plus 12x plus what? So we simply use the idea that we have from before. Our 2ax is going to be 12x. So 2a is going to be 12 and a is going to be 6. So we're going to have the square of x plus 6, which is going to be x squared plus 12x plus 36. So inserting a couple of intermediate steps here, we have, okay, x plus a squared is again x squared plus 2ax plus a squared, and that should equal x squared plus 12x plus whatever it is we're going to add. We can clearly see that the 12 has to equal 2a, so that a equals 12 over 2, which is 6. Okay, I could write, okay, 2a equals 12, so a equals 6, and then x plus a quantity squared equals x plus 6 quantity squared, which is x squared plus 12x, starting off exactly as we have to start off if we're going to complete the square on x squared plus 12x, and then plus 36. And just squaring this binomial in the usual manner. So it's clear that we have to add 36 here, and now we get a perfect square, which would be x plus 6 quantity squared. I haven't bothered to write that out, although I did write it out over here. Now that means that if we want to go back to our 3x squared plus 36x, well, we just multiply back through by the 3, and 3 times 36 is 108, and here we have it. So we would add 108 here and get a perfect square, but that perfect square would still have that 3 on the x squared, and we'd have to deal with the square root. And what we would get would be square root of 3x plus 6 quantity squared. And actually, that's not even correct. Okay, so I've inserted the parentheses, and now it's correct. But you don't really have to worry about this. In almost every application of completing the square, you'll be able to factor out whatever the coefficient is of x squared and complete the square, and then proceed according to whatever the situation is. So there's some extraneous stuff that I've mentioned here, but the bottom line is you want to factor out the coefficient of x squared. Okay, so factor out the coefficient of x squared. so that you're working with just a plain old x squared and complete the square on what's left.